Hello everyone, today we're going to be discussing distance and displacement. And to differentiate these two words, we're going to have some examples. So our first example states that a boy walks 6 meters going east, then move 10 meters going west. What is the distance and displacement traveled by the boy? So to show you the difference between the two, let's first illustrate the movement of the object by drawing diagrams. So it is the boy started moving from the center going east by 6 meters. That's how you represent the movement. And then after reaching the 6 meters east, the boy then moved going to the west by 10 meters. So this is going west. Now remember, distance is a scalar quantity. It only have magnitude. So we're only adding the magnitude of the length. So you have the 6 meters plus your 10 meters. That will give us 16 meters. Distance is the total length traveled by the moving object. In this case, we have 16 meters. On the other hand, displacement is a vector quantity. It has magnitude and direction. So we're going to be showing the magnitude and direction of your 6 meters going east. In this case, since it goes to the left, remember your number line. So you can represent 6 meters to the east by -6. So you have -6 meters, and then 10 meters going west. Since it goes to the right of the number line, you can represent it with +10 meters. So now you have -6 plus 10. That will give you +4 meters, and the direction is west because we follow the value of the higher sign. So displacement is the distance from the point of origin. So this is the point of origin, and then this is the end point. So displacement is the shortest distance from the point of origin up to the end point. In this case, you have 4 meters going west. So let's have another example. So here it says that a cyclist traveled 9 miles going west and 12 miles going south. What is the distance and displacement traveled by the cyclist? Again, let's illustrate our movement using diagram. So the starting point of the cyclist moves 9 miles going west, and then after reaching 9 miles to the west, the cyclist then moves 12 miles. So 12 miles going south. So this is the direction of our cyclist. Now, to find the distance, again, distance is a scalar quantity, so we're just adding the magnitude of the length. So you have the 9 miles plus 12 miles. So now you only have 21 miles as the distance. That is the total length traveled by the object. Displacement is a vector quantity which has magnitude and direction. So let's analyze our diagram. We said that displacement is the shortest distance from the point of origin to the end point. This is your end point. So connecting it, making a straight line. So the distance between the end point to the point of origin is your hypotenuse. So you form here a right triangle because you have a right angle here, and your displacement represents your hypotenuse. So remember hypotenuse, we use the Pythagorean theorem. So to find our displacement, we're gonna use the Pythagorean theorem. So remember, your c square is equals to a square plus b square. So in this case, your a square is your 9 miles. Then your b square is your 12 miles. So you square this, square the 2. So 9 square will gonna give you 81 miles. And then you have the 12 square, we're gonna give you 144 miles. Adding these two, you will have 225 miles. This is equals to c square. So to undo this square, you get the square root of both sides. So square root of c square is c. Square root of 225, this is miles. 225 miles, we're gonna give you 15 miles. And looking at your illustration, the direction is southwest. So that is your displacement, 15 miles southwest. Now let's have another example. Example number 3. A ball dropped from 5 feet table and bounced back by 2 feet. What is the distance and displacement traveled by the ball after the first bounce? So let's first illustrate our movement. So from the starting point, so it drops by 5 feet. So 5 feet is down. And then after reaching the floor or the ground, so after reaching the ground, the ball bounced back by 2 feet, and that is going up. So now let's compute the distance. Again, distance is just magnitude. So we're just adding the 5 feet plus the 2 feet. And your total distance is 7 feet. That is the total length traveled by the moving object. In this case, this is the ball. Displacement is a vector quantity. So let's represent 5 feet down. So using the number line, your 5 feet will be negative 5 feet. And then your 2 feet up, using the number line, it would be positive 2 feet. So adding negative 5 feet plus 2 feet will give you negative 3 feet. So the negative 3 feet means that your displacement is 3 feet down. So if you want to illustrate it, so from the point of origin until the end point, this is the end point. So this is your displacement. That is the shortest distance from the point of origin to the end point with your direction. So there you have it. You have the distance and displacement. I hope that you learned something today. Thank you for watching the video. Have a good day. Bye-bye.